Okay, now we are going to discuss to explain that example, the file distribution time in the P2P system. So how much time it takes. The same example. Suppose the server must send one copy. Okay, so the server has the file one copy. Okay, so the server, it sends one copy to one client. Suppose this is the client, first client. The first client, it gets the movie, the file from the server. So how much time it takes? It will take, because one file is sent on this link, so the time taken on this link, it depends 1 into 100. So because this one client, first client is requesting, so one client is requesting for the file, so one copy of the file will be sent. So n is equal to 1, so 1 into 100 divided by 30, because this bandwidth is 30, so it becomes 3.3 seconds. And when the file is reached here, so now from here to here the time is 0. So from here to here it depends upon this bandwidth, and the D1 bandwidth, it is 5. So one copy is sent here, so 1 into 100 divided by 5, 20 seconds. So its time from here to here, it is 23 seconds. Okay, now the file is present here and here. In the peer-to-peer system, the file, these two users, they can download the file from the server as well as they can download from this client as well. Because in the peer-to-peer system, client also can share the file with others. So suppose these two users, the D2 and UN, they also want to access the file. So one user can download the file from the peer and one user can download the file from the server. So in this case, we can see that it depends NF divided is equal to US plus U1. Okay, so NF is the 200 size in the file, and the bandwidth, that is because you can download the file from here and you can download the file from U1. So so half file can be one can download from here and half can be downloaded from here. Because why n is equal to 200? Because the two users, they are accessing, the UN and D2, they are accessing. So the total file size is 2 into 100, 200. And the user can access the file from here and here. So one can access from here, half of the 100 MB file, it can be accessed from here, and 100 can be accessed from this U1 client. So in this case, it will take 50 seconds. So this makes the downloading faster. This makes the downloading faster. So you can see that generally, if there are n number of users, so if the user have the file, the client, the more client that have a file, the more this bandwidth will be divided, this size will be divided. Okay, so this increase the delay. In the last example, we noted in this example that it took how much time? It took 60 seconds for this client, and for this client it took 10 here and 20 here, 30 seconds. But now for this, in this example, for this D1 client, it took just 3.323 seconds, from 30 to 23 seconds. So this bandwidth is saved. Similarly, when these two users, they are accessing in the P2P system, so their downloading time is how much? It is about 50 seconds. But in the last example, if you do remember, for these two users, for this user it was 60 seconds. Why? Because 10 here and 50 here. Okay, and here it was 10 plus 15, and now it is okay, so it will be less, the 3.3 and 5, 8. So here the bottleneck is this link for this client, and for this one the bottleneck is this one. Okay, So you can see that if there are more peers and they have the file, they can share the file. So this time is divided. In the client server, the delay is f divided by minimum delay, di. But here you can see that it is, the bandwidth is increasing, us plus this one. It is increasing. The more pair they have the file, the more bandwidth you have. The more bandwidth you have, and the more bandwidth you have, the less time it will take. If the denominator value is high, then the overall value will be low. So the less time it will be required. So therefore, in the pure P2P system, as compared to client server system, the delay to download a file is less, is very less. And why less? Because here the burden on the server is reduced. The file can be downloaded from other peers. Okay, so this is the example showing the betterness, the advantage of peer-to-peer system as compared to client server. Okay, so you can see through example that in the client server, if the number of peers increase, the delay increase. Why the delay increase? Because in the client server model, when more number of peers want to access the file, so this bandwidth is shared among more number of peers. If the peers is 3, so this bandwidth is shared by 3. If the peer is 6, then this bandwidth will be shared by 6 peers. So if the bandwidth is shared by 6 peers, so this bandwidth will become less as compared to the bandwidth is shared by 3 peers. Okay, so this is the advantage. This is the logic. In the peer-to-peer system, when the number of peers are increasing, so the delay is not increasing in that range. Okay, the delay is increasing very low. Okay, now we discuss the advantages of peer-to-peer system. That what are its advantages, why it is used as application. Now we discuss how it works. So we will discuss it from two perspectives. The first perspective is from BitTorrent. The BitTorrent protocol, I think more of the all of you they are using torrent. Why you are using torrent? For example, uTorrent, it is used to get the pirated Windows, MX Offices, files, even the manuals, the solution to book, to exercise and books and the movies. Okay, so the BitTorrent protocol, how it works in the, what is first of all torrent? Torrent is the group of peers, group of users exchanging files, and file is not exchanged as a whole. The file can be downloaded in chunks. The file is divided into chunks. So if this user wants to download a file, so it, for example, Tare Zameen Pe, so some part of the file can be downloaded from here, some part of the file can be downloaded from here, some file of part can be downloaded from here. So the file is downloaded in chunks. So some chunks can be downloaded from here, some chunks can be here, some chunks from here. Okay, so this is how it works. And there is a tracker. The tracker, it has the information about all the peers in torrent, all the peers, about all the torrents. Their information is present here in the tracker, that who are the peers at this time. Okay, so when a user, suppose Alice, she wants to join the P2P network, so she contact the trackers, and the tracker provide not the information about all the peers, but it only provides a list of peers, some set of peers, for example 50 peers. So then this connects with some of these peers, okay. So when a user connects with the peers, okay, then this user can share its file with the peers, and this user can also download the files from other peers. And we have discussed that the file is divided into each file that is shared in the torrent. It is divided into chunks. For example, a chunk is 256 kilobyte. Okay, so if the joining pair, it doesn't have no chunks. Okay, if it doesn't have the file, then it can download the file from other peers. Okay, so the peer can also downloading the chunks, but it can also upload the chunks to its neighbors, and how it gets the neighbors information? It can get the neighbor information from the tracker, okay, and the peers may come and go dynamically. For example, this peer can join the peer-to-peer network anytime it wants, and then it can leave after downloading the file. After uploading the file, she can leave it. So it is up to user choice. So the users, they join and leave the network dynamically. Okay, so this is called churn, 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 that the user can join and leave the network dynamically. The joining and leaving of the network, it is called churn. Okay, so we can discuss it later on. It is present here. Okay, this is called peer churn. Peer churn means the user can leave or join the network as it wants. Okay. So we are discussing the BitTorrent. So the user can join and leave the network dynamically. Okay. Once a peer has entire file, once, for example, this peer, it downloads a file from other peers, so then it can also share that file with others. So it depends on the user. So sometimes the user, they are selfish. They only download the files from others, but don't share the file with other people. Don't upload the file. It only downloads. They are selfish. And some people, they are altruistic. They always share the file with others. They provide the content to others. Okay, so it depends on the nature of the people. Okay, so we will discuss that how we can cope with the selfish people later on. We can discuss it. Okay, now how the user. So in this slide we discuss that if the user wants to join the network, so it contacts the tracker, and the tracker provides the list of the peers. Then among these peers, then it can contact with others. Okay, with other peers. So when this, for example, this peer, she wants to join the peer-to-peer network, so she will contact the tracker. The tracker provides a list of the peers. Among this list of peers, she connects with these peers. So these peers becomes the neighbors of this joining peer, this new peer. Okay. Now, if this user, she wants to download the file, how she can download? Okay, let's discuss it. When the user joins the network, so she can pull the chunks. At any given time, different peers have different subset of files. Okay, when this user joins the network, so she connects with the neighbors 1, 2, and 3. She has 3 neighbors. So each peer, they exchange with its neighbor the list of the files that are available. For example, this peer, it will share the list of files that can be downloaded from this peer. So it shared its own shared file list with its peer, with this peer. Similarly, this peer, neighbor peer, it also sends a list of files that can be shared by this peer, that are available with this peer. So it sent a list of files. Similarly, this neighbor also send a list of files that are available at this pair. So in this way, this pair comes to know that which files are available with which neighbors. So each pair is exchanged periodically with its neighbors that which files are available with which pair. Okay, so in this way, this pair, it comes to know that which files are available with this pair, which files are available with this pair, and which files are available with this pair. Okay, so at any given time, different pairs have different subset of files. So periodically, each pair it share the list of chunks that they have. So the ls can come to know about the list of the chunks that their neighbor have. So after coming to know about the files that their neighbor have, the ls can send request for which file? For a missing chunk, for those files that are rearranged. Rearranged means that is available with only a few pairs, with the least number of pairs. So they can download. Why? Because so that it's, for example, if a file is only available with this pair, with a single pair, so she download that file. When she download that file, now this file is available with the two pairs, one this and this. So if the file is available with the more pairs, what does its logic? Because if this pair goes offline, if this pair is disconnected, if it gets switched off, then this file can be downloaded from this as well. This is the logic, that when the neighbor gets the information about its neighbor files, the files present with its neighbor pairs, so it downloads from these neighbor pairs the rearranged file, the file that is available with the less number of pairs. Why? Because so that the file can be available with more pairs. Okay, this is the logic. Similarly, the file a pair can also share its own file with others. So ls sends chunks to 4 neighbors currently sending her chunks at highest rates. So you can see that she may have 50 neighbors, but she only upload to 4. As she can download the file, she can also upload the file. She can share the file with others. So she shared a file with the 4 pairs. With whom 4 pairs? With those pairs who are also sending the file to the ls. This is called tit for tat. Tit for tat means if someone is giving you the file, then you can also give her the file. Okay. So every 30 seconds, so it only sends to 4, so that it not to all peoples. Okay. And also after 30 seconds, the ls selects a new pair, another pair, and it sends that file. This is called choking. Okay. So the file select a random a new pair, the 5th pair, because ls is sending to 4 neighbor pairs. So other than these 4 pairs, the ls also choose randomly a 5th pair, and it also sends her file to 5th pair. This is called unchoke. And the other pairs are choke. The 5 pairs, these 4 5 pairs, they are unchoked. Unchoked means that to these 5 pairs, the ls is providing the files, its own files, sending its own file, sharing its own files. And with the other pairs, they are choked. They cannot access the file from the ls. The ls is not providing the file to any other pairs other than these 5. Okay. So how it works? It is, for example, ls is have these neighbors, 4 neighbors, and the ls is providing them file, sharing the file, and it randomly selects another Bob, unchoke the Bob randomly. Okay, so when they send the file to each others, so they are suppose good people, and the ls, they are the good people, so maybe the ls and Bob, they become good friends, and the Bob can become in its four toppers. So in this way the ls is exploring new neighbors. Okay, so we have discussed the BitTorrent, okay, in detail. Now let's discuss another important concept, which is called DHT. It is a very important concept, and it should be understood. In the DHT, each pair has an identifier. For example, in the range 0 to 2 to the power n minus 1. Okay, so each identifier can be represented by n bits. Similarly, each file that you share, it also has a key, and that key is also in the same range, this same range. That means the identifier of each pair and the identifier of each file, they are in the same range. Okay, so we will discuss what is its advantage later on. So when a file, how the file key is generated? The file key is generated by using hash function, and the hash function can be applied on the file name or on the file content. For example, a file name has Led Zeppelin IV, so we apply on the file name the hash function, and it generates an identifier, and the identifier is in this range. It is in this range. Okay, so that's why it is called distributed hash table. Let's discuss it, how it works. So there is a central issue, okay, that how the file is searched, that which pair has which file. Okay, so let me explain first an example, then it will be, I think, clear. Suppose these are the pairs, they have identifier in the range 1, 3, 4, 5, 8, 10, 12 and 15. They have identifiers, and they are connected. One is connected to 3, to successor and predecessor. Each pair is connected in this circle to its successor. Successor is 3, 3 successor is 4, 4 successor is 5, and so on. And similarly to the predecessor, so the 3 predecessor is 1, the 1 predecessor is 15. This is in a circular form. Okay, now how the file is shared? Suppose this pair, it has identifier 3. Okay, this is a binary representation. This is not 11, it is a binary. So 1 and 2, 3. It's a binary representation. So now if it wants to share a file, and file name is Tare Zameen Pe, so it will apply hash function, and hash function value is suppose this one. So this hash value, its range is in the same range that the pair has these IDs, these identifiers. The range of this hash value is also same. Suppose this value is how much? 1110. So it represents 248. So this is 2, 4, 6, 8, 14. Okay, so who is responsible to store this file? So this file, so to find its key, who is the responsible to share this file? So how it is done? This identifier pair, it has identifier, so it compares its own identifier with this key, for example this identifier, and this is 011, and its difference is with this key is 11. And it also pairs, it knows about its predecessor, this one. So it compares its key with this ID, predecessor ID. So it is 13 difference. And it also know about its successor pair. So it compares the key with its successor key as well, successor identifier as well. So this is 10. So who is closest to this key? The one which has the less difference. So who has less difference? This 10 is less as compared to 13 and 11. So it means that this one is closest. And this one is who? This one is the successor. So this pair, it send the file to this pair. Now this pair, again, it will also does the similar comparison of this key to itself, to its predecessor, and to its successor. So this will become the closest one. So it forwards that file to this until and unless it reach to here. It reach to here. So it means that this is the responsible. So this Tare Zameen Pe movie, this file is stored here. Either this file is stored here or the index information is stored here, that Tare Zameen Pe movie is present with this pair. Okay, so this identifier helps the hash value that is applied on Tare Zameen Pe, it produce a key. And this key, that means that this file will be stored, Tare Zameen Pe movie will be stored on the pair which is closest to this key. And how it is found? It is found like this way. So it is stored here. Now suppose that another pair, okay, suppose another pair, this one, it wants to download the file Tare Zameen Pe. Again, it will apply the hash function over Tare Zameen Pe. It will again generate the same hash value. We call it consistent hashing. Now again, who is responsible for this key 110? So it will do again the same thing. It will compare the same these steps. It will compare this key with itself and with this predecessor and successor. So again, this successor will be closer. So this will forward the request to this pair. This pair will forward to this. This pair will forward to this. So when it comes here, so here the file is stored. So this pair will then send the file to this pair. Okay. So when a pair wants to store a file, so it generates a hash value, and the hash value becomes the key. And the key means that those pair which is closest, which has the ID identifier closer to this key, that file will be stored there. If anyone else wants to download the file, so again that person has to apply the hash function over the movie. It will generate the same key. So it will forward that request to that pair which is closest to this key. So from there it can be, so in this way the file can be found in the peer-to-peer network. Okay, so we have discussed it through an example. So identifier, the peer identifier, each pair has identifier and each file has identifier. And the file identifier is generated by applying the hash function. Okay. So the central issue is assigning the key value to pairs. Okay. So how it is assigned? So I explained it. So the key is assigned is to that pair which has the closest ID. So in this example, as you explained, this file, its key was 110. So among these pairs, who was the closest? This 111 was closest. So it was stored here. Okay. So it was stored here. So it is we mean immediate successor. By closest means immediate successor. For example, if we have 14, so 14 will if you have the key 13, so after 13 which comes 14, 15, so the pair which 14 will become the successor. Similar for 15, the pair 1. Why? Because we have the key from 1 to 15, so there is after 14 there should be 15, but 15 is not present. After this there is 1, so and 1 is present, so 1 will be the successor. Similarly for 8 is 8, because it matched with the 8. Okay, so this is an example, we have explained it. Okay, so the pairs, they can be arranged in this chord structure. This is called chord circle search. Okay, it takes how much time? From here to here, it takes how much time? How much steps? 1, 2, 3, 4, 5, 6. So it takes a longer time, so we can reduce this time. How it can be reduced? Suppose each pair, it maintains links with its predecessor and successor, and also it maintains a link with the pair which is 2 hops away. This is immediate neighbors, and this is after 2 neighbors. 2 neighbors is this one, third neighbor with its third neighbor. If for example this pair is maintaining in another link with its third neighbor, this pair is maintaining another link with its third neighbor, and this pair is maintaining another link with its third neighbor. So what will be its advantages? Definitely, if you have more neighbors, you have more links. If you have more links. Okay, so what is its advantage? What is its advantage? Let's discuss it. Okay, advantage that we